Hello and welcome to yet another video of Cornerstones of Math. Today we will calculate the area enclosed by the graph of absolute value of ln x plus absolute value of ln y equals 1. So in order to calculate the area, obviously we need to draw the graph. Here we have absolute value signs. So let us use this basic property of absolute values to remove them. Basically, for the absolute value of a, if a is non-negative, we can simply write a, but if a is negative, then absolute value of a equals minus a, so that the end result is always non-negative. Here we have absolute values on ln x and ln y, so depending on the signs of ln x and ln y, we have these four cases. And before we handle the equation of the graph, let us express these individual domains in terms of x and y without logarithms. That is, for the first case, this condition is equivalent to x is greater than or equal to 1 and y is greater than or equal to 1. For case 2, we have x is greater than 0 and less than 1 and y is greater than or equal to 1. Here, we need this greater than 0 condition because x and y are both arguments of logarithms. For the third case, we have x is greater than 0 and less than 1, and y is greater than 0 and less than 1. And for the fourth case, x is greater than or equal to 1, and y is greater than 0 and less than 1. And on the xy plane, these four cases correspond to these regions. So what we are going to do now is to investigate how the graph looks like in each region. First, when x and y are both greater than or equal to 1. In this case, ln x and ln y are both non-negative, so the equation becomes simply ln x plus ln y equals 1. So ln xy equals 1, so xy equals e, so we have y equals e over x. This is the very basic hyperbola, so in this region, the graph looks like this, a part of the hyperbola. Next, when x is in between 0 and 1 and y is greater than or equal to 1, the green shaded region in the figure. Here, ln x becomes negative, so we have minus ln x, but ln y is positive in this region, so we have plus ln y. So this equals 1, so ln y over x equals 1, so y over x equals e, so we have y equals ex. So now we have the straight line. If we sketch this, we obtain this graph. The straight line y equals ex. For the third case of x and y both in between 0 and 1, now ln x and ln y are both negative, so minus ln x minus ln y equals 1, so minus ln xy equals 1, so ln xy equals minus 1, so now we have xy equals 1 over e, which gives y equals 1 over ex. This is another hyperbola, but compared to y equals e over x from the first case, 1 over x is now multiplied with smaller number, which is 1 over e, so the hyperbola is closer to the origin. So we have this graph. Finally, in the fourth region, now ln x is positive while ln y is negative, so ln x minus ln y equals 1, so ln x over y equals 1, so x over y equals e, so y equals x over e. So we have another straight line, now with much smaller slope of 1 over e, which is this straight line. So now we have obtained the entire graph. And as you can see, the graph forms a closed curve, and the region enclosed by the graph is this shaded region. And let us calculate the area of this region by integral. So the area A of the shaded region is, first, let us assign these points or vertices A, B, C, and D. Then A equals the area of the shape BCD plus the area of the shape ABD. As for the shape BCD, it is the region between the straight line y equals EX and the hyperbola y equals 1 over EX. So integral EX minus 1 over EX dx from 1 over E to 1. And as for the shape ABD, it is the region between the hyperbola y equals E over X and the straight line y equals X over E. So integral E over X minus X over E dx now from 1 to E. So if we integrate, for the first one we obtain E over 2x squared minus 1 over E ln absolute x. And for the second one, we have E ln absolute x minus 1 over 2E x squared. And if you calculate this, you will obtain E minus 1 over E. And this is the area of the shaded region in the figure. And that's all for today's video. Thank you all for watching. If you enjoyed this video, please don't forget to hit that like and subscribe buttons, and I will see you in another video.